Hello and welcome to lecture number 5. Up until the last class, we discussed about the law of chemical combination, where we discussed about the law of conservation of mass and law of definite or constant proportion. Today, we're going to discuss two very important laws, which is basically useful for numericals where they involve volume, gases. Yeah. So let's begin. So those laws are Gay-Lussac's law of gaseous volume and Avogadro's law. So we'll be discussing both the laws today. So let's begin. So first, let's talk about Gay-Lussac's law of gaseous volume. So what does it say? Let's have a look. By the way, as the name suggests, it's only applicable for gases, right? Now, see, they say that whenever two gases combine, they do so in such a way that their volume ratio is same as moles ratio. Let me explain. See, like for example, you have, of course, it was processed by Gay-Lussac, and it says suppose you have 100 milliliters of hydrogen combining with 50 milliliters of oxygen, then what do we get? 100 milliliters of water vapor. What is the equation governing it? Yes, H2 plus O2 gives you 100. Now, how exactly we get this? Let me explain this part. See, have a look. Hydrogen plus oxygen giving you water, right? Now, see, what would be the ratio of this? So 2 is to 1 is to 2. What can we say? We can say that 2 volume, yes, 2 volume reacts with 1 volume to give us 2 volume. Because if the temperature pressure is same, then we can say instead of 2 moles, we can say 2 volume also. This is a very important thing. Please note this point down. That if you ever see that the question says the same temperature and pressure, and we have only gases involved, right? Then moles is same as good as saying volume. Like instead of 2 mole, I can say 2 volume. I can say 2 liter. I can say 20 liter. I can say 200 liters, whatever I want. The ratio of moles, 1 mole, 2 mole, 1 mole, okay, will be maintained. As in, if this is 2 liters, this would be 1 liter, and this will be 2 liters. If this is 20 liters, this will be 10 liters, and this will be 20 liters. So that's how the ratio continues, right? So that's how the ratio is determined. 20, 10, 20, 200, 100, 200. So this is what Gay-Lussac's law say. Okay. Next one, like we can see another example. There's the explanation of the same thing. See, H2 reacts with each other to give you this. So it combines in the ratio 2 is to 1. This is what it says. Okay. Now the next law that we have to study is Avogadro's law. Let's see what it says. Avogadro's law says that for two containers, for containers having same temperature and pressure, same temperature and pressure, volume is proportional to moles. It is just an extension of what we learned before. What does it mean? Please understand this very carefully. It says that if there is a container, okay, suppose this is a container, pardon my diagram, yeah. Suppose there are two containers. Then it says, if suppose the temperature of this container is T and volume the pressure is P1, the temperature of this is T2 and the volume is P2, pressure is P2. Then it says that if we can also say if the volume is same, for example, if I say that it's 1 liter and if it is also 1 liter, then the number of moles will be the same. Irrespective of what gas we have, it will be the same. This is another best way to understand this law. It says if temperature pressure is same, okay, if the temperature is T1 and pressure is P1, volume is same, then no matter which gas you have, whether we have a tiny gas like helium or a big gas like SO3, no matter what gas we have, the number of molecules of those gases will be the same. So I hope you understood what I'm trying to say. This is what Avogadro law means. Essentially, this is what Avogadro law says. So we've discussed two laws today. Both are gaseous law, very important for numericals. So let me give you one quick question on this, and then we can go to the next topic, which is atomic mass and molecular mass. So let's begin. So please do this question. The question is, if 10 milliliters of hydrogen reacts with 5 milliliters of oxygen, what is the amount of water vapor produced? This is one question, and this is the next question. There's a container, pressure is 1 atm, temperature is 0 degrees Celsius, STP. There's another container, pressure 1 atm, temperature 0 degrees Celsius. This contains hydrogen gas, this contains acetylene. The question is, what will be the volume of, if the volume of this is 1 liter and the volume of this is 1 liter, then what will be the ratio of, or what will be the relation between moles of hydrogen, number of molecules of hydrogen and number of molecules of acetylene? So this is the question. I mean, is it this or this? Or third option, same. So that's the question. So please attempt both the questions. So you can pause the video and do both the questions. So I hope you've tried doing both the questions. Now you can see their solutions. Okay, so let's begin with the solution. For the first question, how to solve it? See, we know that H2 reacts with O2 to form H2O, and the ratio is 2 is to 1 is to 2. So 2 volume will react with 2 mole, reacts with 1 mole to form 2 mole, right? So instead of 2 mole, I can also say 20 milliliters reacts with 10 milliliters to give you, yes, 20 milliliters. I can also say 10 milliliter will react with 5 milliliter to give you 10 milliliter. So what's the answer? 10 milliliter. Simple. Now, moving on to this question. So the answer is 10 milliliters. Moving on to the next one. See, what is the next question saying? That if this is the container having hydrogen gas, this container has acetylene gas, C2H2. So how many molecules are present if the temperature and pressure is same? So hydrogen is a very tiny gas, right? But acetylene is a big gas, right? What would be the answer? Do you have more amounts of hydrogen? Of course, no. As per Avogadro's law, it should be same, because pressure, temperature, and volume is same. So number of moles will also be same. So based on this, answer is third one. That's how we can approach this law. So I hope these two laws were useful to you and you've understood how to attempt questions on this. So from now onwards, you can obviously take volume as moles, moles as volume, given the condition of pressure, temperature, same. Okay, so that is the end of this law. Now we have to discuss the next topic, which is atomic mass and molecular mass, which will be the topic for our next class. So in the next session, we'll start with atomic and molecular mass. That's it for today. Thank you.